Hello everyone. Today we'll talk about the Ohm's law and how we can use Ohm's law equations to solve circuit problems. So Ohm's law is V is equal to I, the current, times resistance R, or R is equal to V over I, or I is equal to V over R. So it's the same equation but written three different ways. So in order to use these three equations to solve a circuit problem that involves voltage and currents and resistance, we do a couple of questions. So you could have one battery that is connected to a resistor and close like that. Well, not really close, but now it's closed. And this is the most simple series circuit. And to make things simple as possible, let's say this is 1 ohms. Let's say this is 5 volts. And so in this type of most simple question, they might ask you what is the total voltage, which is 5 volts, so it's given to you. Total resistance is 1 ohms, it's given to you. And they may ask you to figure out total currents, which is IT. And so I total. And so in order to figure this out, you just have to use this equation. I is equal to V over R. So in this case, I total is equal to V total over R total. So V total is 5 volts. R total is 1 ohms. So the IT here is 5 amps. And then that's it. You're done. Another question they could ask you is like, you could have the same battery, but now instead of one resistor, they might give you two resistor. My resistor looks kind of bad, but it does tell the story. So here it is. This is 1 ohms. Let's say this is 1 ohms. And so this one again, they might ask you what's the I total. So when it's in series, the resistance they add up. So RT is equal to, let's say this is the resistance 1 and let's say this is the resistor 2. So if you have resistor 1 and resistor 2, then the total resistance is R1 plus R2. So in this case, RT, our total, is equal to 1 plus 1. So then that gives you 2 ohms. And so in order to figure out I total, all you have to do is VT over RT. VT was 5 volts, RT was 2 ohms. So the IT is 2.5 amps. So then that is that. Now, let's do another one. Let me just scroll down. Let's do another one. What if you have a parallel circuit? So it's similar to the one we just did, but instead of series, let's say you have a battery, and then you go up, and you have resistor over here, and then you have another resistor over here, and then let's say this is 1 ohms, and this is 1 ohms, and let's say this is 5 volts. So up here we did series circuit, and down here this is like the resistors are parallel to each other. So this is what we call parallel circuit. And so with parallel, we have to ask the same question, what's the I total? They may ask you the I total. And in order to figure out I total, which is the current total, we need to know the resistance total. So then we can use the Ohm's law. And resistance total, we don't know. So in order to figure it out, we have to use the equation RT, which is resistance total. Here, you have to use different equation, which is 1 over RT is equal to 1 over R1 plus 1 over R2. So you have to use this equation because in parallel, resistance gets to be added up differently. And this is the equation that we have to use. And so here, 1 over RT is equal to 1 over 1 plus 1 over 1. And that gives you 2 over 1. And so in order to make this equal to RT, what you could do is you could actually flip this fraction. So you could take a reciprocal of these fractions. So you can put the denominator to the numerator, and you can put numerator to the denominator. And as long as you do it the same way, both sides of the equations, then you can get the correct answer. So for example, you have 1 over 3 is equal to 2 over 6. As long as you do the same thing to both sides, then you could have, this could become 3 over 1 is equal to 6 over 2, which is still equal. So that's what you can do. So here, when you flip it, then you get RT over 1 is equal to 1 over 2. And anything over 1 is stay as it is. So RT is equal to 1 over 2. So in this case, 1 over 2 is 0.5. So I'll just say 0.5 ohms. And now that we know the resistance total is 0.5 ohms, now we can figure out the I total. And I total in this case is IT is equal to VT over RT. VT was 5 volts. RT is 0.5 ohms. So then now you have IT that is 10 amps. Okay. And now that you have know the I total as 10 amps, you can now go and figure out the current that you're going to have individually. So let's call this R1 and let's call this R2. So this is the R1, this is R2, and they're 1 ohms each. So now we can figure out the current for in each of these paths. One way to do it is like the total current is 10 amps, and since the resistance are equal, you could just do 10 amps divided by 2. But sometimes the resistance is different between R1 and R2. So what you can do is you can use the law of voltage in parallel circuit. So voltage doesn't really change in parallel. So if you have 5 volts starting here, when it meets this junction where it actually split, you have 5 volts here and 5 volt here. And so you will have 5 volts going to both pathways. So since you are going to have 5 volts, that means V1 is 5 volts and V2 will be 5 volts. So let's delete that. We'll say IT is 10 amps. And this one, V2 is 5 volts. And R1 was 1 ohms. And R2 was 1 ohms. And so you could have I1, which is equal to V1 over R1. So in this case, 5 volts over 1 ohms, which gives you 5 amps. And for resistance 2 or resistor 2, you again have I2 is equal to V2 over R2, which gives you 5 volts over 1 ohms. So that would give you 5 amps. Okay, so that's the way to figure out the parallel circuit. All right, let's do another one.